everybody, my name is Alexa Hale and I'm a grad student with the Department of Engineering under the EDGE program at the University of Florida. I currently work full-time as an environmental project manager here in Houston, Texas with the company AEI Consultants, a nationwide environmental consulting firm. With my position, I mostly perform Phase 1 environmental site assessments but hope to further my career into performing site remediation under Phase 2s in the future. Living in Houston, Texas, we obviously face multiple environmental issues ranging from flooding, hurricanes, tropical storms, and especially oil spills that occur in the Gulf of Mexico. Hence why I wanted to focus my research paper on oil spill cleanup using activated carbon alternatives. Houston is known to be a major global petrochemical hub. This brings both pros and cons to the region within the Houston Shipping Channel, Galveston Bay, and further along into the Gulf of Mexico. Contamination can occur by oil drilling, accidents with oil tankers, processes, runoffs from offshore oil explorations and productions, but these oil spills can occur on land as well, not just in the water. For example, in 2005, due to Hurricane Katrina, the damages caused about 7 million gallons of oil to be spilled into the Gulf of Mexico from multiple resources, both on land and water. Approximately 3.2 tons of oil is discharged into the marine environment annually into the Gulf of Mexico. These releases can affect the aquatic environment surrounding the region, which in turn harms the organisms underwater and those that live around the water surface as well, which also includes human food sources, which should be a concern for human health. Most people will think, well, how does that cause problems for me really if it's just affecting the animals and the organisms under the water? Well, pollution by petroleum oils also affect the economy, tourism, and leisure activities because the oil coating properties on materials applies a slick layer onto the water and the surrounding area as well. Over the years, there have been multiple cleanup techniques that have been developed to help contain and absorb these oil spills that do occur often. For example, there's containment booms, skimmers, sorbents, dispersion, and in-situ burning as well. For my research paper, I wanted to focus more on an eco-friendly alternative that could be applied for oil spill cleanups rather than what we are using today. Recently, Egyptian researchers found that magnetic activated carbon can be used as an eco-friendly method to absorb and separate oil spills. There are various agricultural substitutes that could be used as adsorbents for oil spill cleanup. For example, there's rice straw, cotton peat, moss, cotton grass, coconut shells, wheat straws, uncooked corn cobs, and the focus of my research paper, water hyacinth. These sorbents are not only natural and more eco-friendly, but they are also more cost-efficient versus the current cleanup techniques that are used today. In my paper, I plan to further discuss in detail how water hyacinth can produce nanomagnetic activated carbon. Water hyacinth tends to have a rapid growth rate with huge quantities that have a negative impact on aquatic life. Therefore, by using water hyacinth to produce nanomagnetic activated carbon, it turns an invasive species to aquatic life into an efficient oil spill solution. Nanomagnetic activated carbon is extracted from the water hyacinth plant from two different segments, the roots and the shoots. By carbonizing these segments, there is an increase in both the surface area and the pore volume, which will create better adsorption properties.